Cool. So we have a small little crowd today, but I super love little intimate environments like this. So I do have a presentation, and I can go through some of it, but I'm happy to jump into different parts. And if people want to hear specific things, or if like we want to just stop, with the size of the room, we can just stop and talk about different topics deeply. Or if there were certain questions about Loom you guys had, I'd love to go into it. So I'm going to jump into my slides, and then I'll kind of hopefully just shift this talk based on how what the audience is feeling like today. So, of course the pointer is not going to work for me. So actually we're going to start this talk about 20 years ago. So when I was a kid, I used to play this game called Magic the Gathering. Has anybody here ever played Magic the Gathering or Pokemon or Yu-Gi-Oh or? Wow, not a single person today. I was sure if this is a nerdy enough room now. But anyways, I used to play these battle card games when I was in school. And when we started doing a lot of blockchain development, we thought it was really natural to want to put a battle card game on the blockchain, because what do you do in a battle card game? You collect cards, you trade cards, you're always you have all these really collectible items that have scarcity to them, and that you want to give to other people that have value. And there's big marketplaces of these cards. So this is one of the first apps we wanted to build. We wanted to build Zombie Battleground, which was like a Hearthstone clone on the blockchain. And at the time, there was really no technology available. This was like 18 months, 2 years ago. There was no technology at the time that was fast enough. And that's kind of where we had started with Loom. We said, we wanted to build a scalable technology, and this was kind of one of the first initial driving forces for wanting to build that scalable technology. So I think if we step back, and what was kind of the big driver for all this, when Ethereum had the ERC 721, that was what kind of initially blew up gaming on the blockchain. And of course, we had that moment, which was the CryptoKitties moment, right? Where we had a mini Ponzi scheme of little collectible characters that everybody loved to trade and have fun with. And it was okay, it was really cool, and at the time that it destroyed the the Ethereum network. So obviously we know that. And then we were it brought non-fungible tokens to proof of work networks. And I think that was a big revolution, right? But none of the game actually ran on the Ethereum blockchain. The only thing that ran was minting the bunnies and trading stuff, right? So we wanted to actually see the full game, all of the business logic actually run on the blockchain. So that's where we actually started with a DPOS solution. And we think that DPOS is right now the best compromise between a full proof of stake and a proof of work system. So I think a lot of people think that DPOS systems are a lot more centralized because there's a lot less stakeholders, but each of the stakeholders has pretty huge amounts of money at stake to not compromise the chain. And then we also use Ethereum as kind of the master chain for things that are very valuable. So if there's things that are worth millions of dollars, you're not going to put it on our chain. You're going to keep that on Ethereum mainnet. But maybe as our chain grows in value, more and more valuable transactions can come to the chain. So we think that sidechains are kind of the best of both worlds. So you have proof of work networks that are kind of securing the larger assets, the more important assets, and that we have these very fast sidechains, DPOS networks, that are actually running real applications, running the full game, maybe even doing low value marketplace trading, these kinds of things, at a much higher scale than we can currently do with a proof of work network. So what does that mean? We can actually run a full battle card game on the blockchain. So this is actually a screenshot from our game called Relentless, what was called Zombie Battleground before. And it's a full card game that you run. So every time you move a card onto the play, every time you attack a card, every time you touch the deck, you actually hit a transaction onto the blockchain. So one game could have 100, 200 transactions between two players. And you can't charge pennies for this, right? It has to be virtually free for those transactions for those users. So you have to have a huge amount of capacity to be able to have hundreds and hundreds of these kind of games going on, running on a dedicated chain. That's why we needed to build our own dedicated chains. And I think a lot of people will step back and they'll say, why do I need to run the game on the blockchain? You know, I just have my assets on the blockchain. I don't need the business logic of the game on the blockchain. I say, actually, a lot of really, really interesting things open up when the game's on the blockchain. So let's say that you could now upload EVM, you could have players upload EVM contracts into the game and change how the game works. They could even do things like, they could have a pay tournament where you have to pay ETH to be able to play in the tournament and the winner gets all the money. And because you're on the blockchain, you already have programmable money. So now you have this modding system that's not just mods on the local client. You can have server-side mods that are secure, that are running in trusted code inside the EVM. So we think that this is going to be kind of a pretty huge revolution to games. And one of the reasons we focused on games first is we think that this is going to be actually one of the first initial drivers of real blockchain adoption with average users. So like, we initially minted 2 million cards on our sidechain like instantaneously. And that's kind of like the start of why we wanted to build the Loom SDK. And the rest of this talk is going to be about what the Loom SDK is, the kind of issues that we've run into with Tendermint. Since I know there's a lot of Tendermint people here, I wanted to also kind of go into that. We have some Merkle tree people, so we'll talk about that, and we'll jump into wherever. So just really, really quick about me. I've been a Go developer for 5 years, spoken around the world, and a fun fact is I rode into my wedding on an elephant. So, cool. Awesome. So I think there's a couple people that came in, and since we have a very small audience, I'm just going to say hi to everybody and just make everybody feel really uncomfortable. So, you, sir?
Hi.
And which group, which project are you working on?
Oh, I'm from a validator called Figment Networks.
Oh, nice. I think I've talked to you guys before.
Yep.
And how about you?
Felix from Coruscant.
Oh, right. Sorry, I didn't notice the shirt. Sorry, Doc. And
I'm essentially media. I was just running some interviews. I'd be interviewing you later, so I thought I'd come and watch.
I was like to be interviewed, so that's okay. That sounds good. Awesome. So what is the Loom SDK? It's an EVM-based DPOS chain. We have a mainnet we call the Loom mainnet or the plasma chain, but we also allow other people to spin up their own side chains. So there's dedicated chains for a couple other projects have, like Battle Racers and a few other teams have their own dedicated chains, but then you can also just deploy your EVM onto our mainnet. And we have a whole bunch of validators. A couple of the validators here are actually running nodes right now. We actually already have IPC with Tron and Ethereum. We have multi-chain signing, which we'll kind of get into later. And we have Plasma Cash, although we're kind of moving away from the whole Plasma thing because we think that right now the usability of Plasma is not there. We like to call ourselves the EOS on Ethereum. So you get all the benefits of EOS while still being able to retain all the benefits of Ethereum, essentially. So the EVM, all batteries included. So we have full truffle support, Solidity, we're Web3 compatible, all that fun stuff. So you can just deploy any existing EVM-based application onto our chain, no problem, no questions there. So what I think is really kind of interesting has been our approach to IBC. So we kind of announced a bunch of partnerships earlier this year. Ethereum, we've had a bridge to Ethereum now for about 6 months. So you can take ERC20s, ERC721s, and ETH in and out of our chain. So for example, if you have DAI stablecoins and you want to use DAI stablecoins inside of your game on our chain, you can do that. So we actually run an NFT marketplace on our chain, and you can actually move those tokens and use them inside of the sidechain as the same way you would use them in Ethereum. And we recently launched Tron integration about 2 weeks ago. So you can actually take Tron tokens, and you can have an EVM contract take Tron tokens and take ERC20 tokens. So what's going to be happening is, over the next couple months, we already have a deal with Binance. So any token that's listed on the Binance DEX will immediately be available to anybody writing smart contracts on our chain. We had to push back the Cosmos just a bit because we needed to do Binance, but we will also be integrating Cosmos once they have more NFT standards and other things on their chain. And we hope to get EOS probably late this year. So that's something that we're really excited about. What we think about is that as a dApp developer, the dApp developer doesn't care about the chains as much as us people developing the chains. And what they want is they want to be able to deploy their dApp, and they want to be able to take payments from all the different chains. And if they have like an NFT asset, like an ERC721, they want to be able to push it to each of the other chains. So they want to be able to get the most market penetration, the most users to their dApps. So we've been doing some fun promotions with the different chains. So in our game, we gave Jaquan a pretty cool card here. I think Zachy got one also. And probably not as popular around here, but we think this is the most hilarious representation of Justin's son. So I think, and actually he really loves it. He's retweeted it about 3 times at this point. So, but we try to do some fun promotions with everybody to show that we're trying to be really neutral about the network. So that's one of the reasons we picked Tron first, because we know it's a very polarizing chain. And we're saying, like, look, we're very neutral on our integrations with these other chains. We're going to be very pragmatic about, there's a lot of users in Asia that are using Tron. There's a lot of users in Europe that are using EOS. You know, we're going to go there. Universal signing. I'm not sure if anybody else is doing this, but we think that this is really cool. So we actually made this picture from, I forget the movie now, where there's a movie where you actually put the fish in your ear and then you can hear any single language. Do you guys know this?
Hitchhiker's Guide to the Galaxy.
Yeah.
Babelfish.
Babelfish. That's it, the Babelfish. Thank you. So we believe in the Babelfish, and what does that mean is, like, you can use MetaMask, you can use TronLink, you can use Scatter to sign transactions on our chain. So you have a private key identity on our chain, but you can actually link it to an address on another chain. You can say, well, I don't really use your chain that much, but I have an ETH identity. I'm always going to sign my transactions with my ETH private key. And you can actually associate your MetaMask account with a public address on our chain. Or you can associate a Tron address with an address on our chain. So that means that, like, if you're only a Tron user, you only use Tron games, you can use TronLink to use dApps that are deployed on our chain. And same with MetaMask. And also, what's probably somewhat controversial is we've seen some people do custody of private keys for users. So what we're seeing is a lot of games, they'll just hold the private key custody for the end users until the user cares about crypto. Because a lot of these people are coming into these games, they're like, this is kind of a cool game, crypto, I don't know, I'm gonna play it, I don't know what a private key is, you just manage it, I'll log in. And then maybe later on, when they're like a little bit more competent, they could take over their own private key management, so that way they could trade, or if they want to own the assets independently. And I think that that's going to be a model that we see more and more. So just to get started, we have pretty cool reference. I'm sure people have seen Crypto Zombies. We have a whole bunch of tutorials on coding Solidity and whatnot. The chain is open source very recently, so you can take a look. And I kind of went through that very quickly because I wanted to have a whole bunch of time to talk about Tendermint, because we're at a Tendermint conference, or Tendermint Cosmos conference. I wanted to talk about how it's running the chain in production has. So I believe we're one of the longest running Tendermint chains. We have a chain that's been live in production for over a year. And we have 2 other chains that have been live for about 8 to 10 months at this point. So before I go into like the nitty-gritty of like running a Tendermint chain in production, did anybody have questions just about what Loom is and like what we're doing and deploying apps or anything? Yep.
As you told, you are focused on blockchain games. So I have a question. Do you have, did you solve the problem about verifiable distributed source of randomness? Or you just don't use any random at all?
Oh, so the good question about random. Yeah, so the random is something that we have ongoing work on. So we have a couple methodologies of doing random. One is you can use the normal way, which, you know, if you're smart enough to read the blockchain, you can guess the random based on the hashes, right? The other thing is you can have random that is secret to the validators only. So while some people would say, oh man, but what if the validators collude? But in a lot of games, that's probably good enough. Basically, we can have like a secret that's a commit and reveal between the validators. But that wouldn't be necessarily good enough for a gambling game, right? Because a gambling game, you have money at stake. Maybe one of the validators, he starts leaking the random numbers because then he could make money on it. So that is something we haven't solved, but one of the things that I think we're looking at is, well, there's two ways you can do it. You can do a provably fair method, right? Where the client encrypts something and then the server encrypts something and you generate a random between it. The other method is, there was actually somebody here at the Cosmos conference that was talking about the random beacon. We think that that could be an interesting way of handling the randoms.
Beacon, the Gaming Foundation?
Say that again?
Are you talking about the Gaming Foundation?
Yeah.
Okay, we worked on it.
Oh, wow. You got worked on everything.
That's why I'm asking about how did you solve the problem? Maybe you have another solution, not using the last signatures, maybe you found something else.
Yeah, so I mean,
fancy.
so the problem is the majority of the games that we've had so far have not had things more than hundreds of dollars of value at stake because of the random. So it didn't necessarily make sense to do more than a commit and reveal. But I really liked your random beacon, so I think that we're going to actively look at seeing if we can integrate that into our chain.
Thank you.
Cool. Anything else before I jump into the Tendermint stuff? Cool. Awesome. So, one of my fun things that I don't get to talk about too much, especially at blockchain conferences, because very few people are running their own blockchain, is the pain of running a blockchain in production for over a year, and upgrading and adding in validators and being able to like actually migrate the data. What happens when you need to change the format of the data? So I want to delve in, and if there's anything that you guys ever like had issues with or you're just curious about, I'm happy to like delve into more detail. But I'll start at some high-level stuff, which is first is monitoring. Monitoring a blockchain is incredibly difficult, right? Because typically you're monitoring your node if you're running a validator, right? Maybe you have some kind of logs, you're alerting on your logs, you're alerting on your metrics. But what do you do when you have 20 or 100 disparate validators and all of a sudden the blocks start to increase in length? We had an issue where like all of a sudden our blocks were going from 1.5 seconds to 5 seconds to 7 seconds before they would close, right? And you're like, how do you debug that? And one of the things that we have been working on and that we're slowly trying to push out is that we actually think that it's worthwhile for there to be some centralized monitoring of the chain to be able to help diagnose it, right? So actually on the Loom chain, we have an optional way for you to push metrics to us. And it's basically just the typical like Prometheus style metrics that would come out of Geth or come out of Tendermint. But we allow you to put it to us centrally, and then we'll keep an eye on these things. And then sometimes we even poke different teams and we're like, look, we see that for some reason on your node, it always takes twice as long to process a transaction. Well, it turned out somebody had a RAID controller that would actually make the transactions twice as slow, even though the RAID controller was supposed to speed up the speed of the disk. And we do these little things because as we scale, like a lot of the validators are running really good setups. We see they run HA, they're running on really big hardware. But sometimes you have a lot of little validators that have, maybe 1% stake or something, and they're hosting 5 other chains. So they're not necessarily paying attention to every single chain. So we think that actually having some level of centralized management is really good. I know Ethereum has this too, where there's some group that actually runs ETH stats or something, and you can optionally push metrics into it. I think that more blockchains should do this. It would be great if there was a way that we could do it where Loom wasn't running it, because it just still feels very centralized, and we're like, oh, hey, your node is slow, but I think that this is a fair compromise. And we're huge fans of Prometheus and Grafana. I think that they're really the best metrics and monitoring tools. So if you're not using them, I would definitely check them out. The next level is upgrades. I think every single chain has had some issue with upgrades. I think Ethereum has literally probably been the best chain about upgrades, but the upgrades are much slower paced. So it's like an 8-month cycle or something like that for an upgrade. Whereas we've been upgrading our chain at least every 2 weeks, sometimes every week, depending on, because we're rolling out new features, we're rolling out bugs, performance issues, just constantly. And I think a lot of other chains that are going to be competitive feature-wise, because as soon as your chain works and you have people deploying, you just have an endless queue of people asking you for new features. Literally every day, my Telegram is just 12 people asking me for new features. So you have to be able to roll out these upgrades. But what we've seen is it's really, really hard to upgrade a blockchain, right? Because it's well, what if you need to upgrade the underlying database of the blockchain? So we had an instance where one of our Merkle trees was, the way we were writing into the Merkle tree was very unperforming. So we were doing too many key value writes, and it was creating these really massively large Merkle trees. And we needed to upgrade this, but the upgrade process takes 5 hours because we had 200 gigs of data, right? So we actually had to do this thing where you would boot the new version, it would start to build the new database, and as it ran, it would just it would have to write to both databases at the same time. Now, granted, then it took 12 hours, but it was fine because the chain didn't have to go down during this period. But we had to actually write this thing that would actually do dual writes to both databases, make sure that the hashes are matching at both databases, and then at a certain height, switch it off so that way it's only writing to the new one. So that was one approach we've taken. So things like smart contracts. So a lot of chains, if you look at Cosmos, they have native transfers, and it's actually built into the chain. So we have this too, right? So there's things like DPOS and staking that tend to be, almost in all the chains, are native functions. They're not part of a Solidity smart contract, right? So upgrading those is really difficult, because what do? If you've ever looked at the old Steemit code, so Steemit, I think, was one of the first really fully featured blockchains, right? And if you look at their code, every other line of code says, if height 744 or above, do this. If height 7888, do this, right? And I think that is just, it gets to the point where literally 80% of the Steemit code was just if then else's about block heights. And then it's well, what's even worse is if you have this, and then you have 6 other people that are running networks that are using your code, right? And then their block heights aren't going to match your block heights, right? So one of the strategies we've used is we actually have multiple versions of the contract. So the coin, in our network, coin is written in Go, and DPOS is written in Go. And we actually have multiple versions of those contracts. And what we do is we have a thing that can actually switch them at different heights. So if you're just a new person and you download our chain just from the internet, you're going to get the newest version of the contract on your chain. But if you're us and you're running an older version, up to a certain height, we actually have a way for the entire chain to activate a feature midway. So that way you don't have to have downtime when you do application level upgrades. Tendermint is actually the hardest thing. Because there's no upgrade process on Tendermint right now, we're trying to work with the Tendermint team. So literally if you upgrade Tendermint, you have to make sure that all the nodes get to a certain height, stop all the nodes, then start them all, and hope that nobody was behind. Because if anybody was behind, there's no way for them to ever catch up again. So the strategy we've actually taken with upgrading Tendermint is we just backport everything that is not compatibility breaking. And that's not the way we would like to do it, but that's something that we're trying to actively work with the Tendermint team. But it's a really difficult problem. It's like, how do you upgrade your P2P layer while your network is running and have multiple versions of your P2P layer? It's like really, 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 really tricky problem. And I think most people don't realize because they've not had to deal with this because they add 3 functions to their blockchain a year. You know, like when we see chains like ours, Cosmos, and these, where you're going to see new features every couple of weeks. You're going to find this is going to happen more and more often. I think, talk about virtual machines. So we're running EVM on Tendermint. I think that virtual machines are going to be the future of how we're going to build stuff on blockchains. So I think because one of the problems is if you build things into your binary and you need to change that, all of a sudden you have very difficult ways of doing the upgrade because the binary has to be able to support both versions. But anytime you put something into a virtual machine, you can just have both blobs of the virtual machine, and the virtual machine will just decide which blob it runs at different heights. So it naturally makes sense that over time, you want to be able to shift as much of the logic of the blockchain into virtual machines, and particularly as they get faster. EVM, hopefully, will be getting faster, but then I think a lot of the chains are moving to WASM, and I think maybe next year we'll see ourselves doing a lot more WASM stuff, maybe even EVM on WASM, who knows? So for the future of Tendermint, I think there's a few things that I'd like to see, kind of. One of the things that I spent my week here doing is trying to work on a new IAVL store. So we have a working group now, about 12, 15 different people that are actually actively looking at how do we rewrite the IAVL store? How do we get a lot more performance out of it? Because right now that's the biggest, I would say that that's probably the current biggest bottleneck because we're saturating the IO and it's quite slow. So I think that there's going to be a lot of work on how we actually optimize these Merkle trees. You know, do we make them immutable? Do we need to really keep every single block? You know, these kinds of optimizations are going to have to come. A really interesting area of Tendermint that I don't know a lot of people play with is reactors. So in Tendermint, they don't actually expose this, but they have all these P2P reactors. So like, if you want to build new custom things on top of their P2P layer that doesn't actually use PBFT, like say that you want to have something that does like partial PFTT, or if you want less security, or you just want to broadcast things, like say you wanted to broadcast some random info that's just private to the validators, you can actually just do these custom reactors. And I think there's not a lot of activeness in Tendermint to be able to actually expose this functionality, so I would love to see them like actually like make that a little bit more first class. The same thing, you can't really change how the PBFT works. You can't run multiple PBFT engines inside the same Tendermint process. So like we wanted to have multiple PBFTs for maybe running multiple networks or having different scenarios where there's different data sets. But there's not like a clear way to do that, and that's something I would love to see. And then of course, upgrading. So I think we're at a Tendermint conference, so I have to always address, how do I feel versus Tendermint versus all the new ones? So we have Aurora Boreal, I can never say that one, the one from Cardano. We have the one from Polkadot, Grandpa. We have a few others. And I've taken a look at a lot of them, and one of the things that I've noticed is we've been running Tendermint for over a year, probably about 14, 15 months. It took a lot of beating to like get Tendermint to the level of stability to be able to run actual production systems and not have them either crash or just get into random states that you don't know how to get out of, right? And it's like, it's very small grinding, so like each of these systems, even if they are 25% better or something like this, I really think that they're going to take multiple years before they're actually going to be in a state that's actually going to be really usable for production class applications. Sure, if all your chain does is like stake tokens and do a transfer once a day, okay, sure. But if you want to run like a game, you want to run, you know, a finance application, your chain can't just like randomly like halt during the day because your algorithm is like not been debugged very well. So I guess the main takeaways, and I know this has been quite fast, is I think that there's a multi-chain future. I think you've been hearing that a lot in IBC talks, but I think of it a bit differently. I think that the app developers don't really want to care as much about what chain they're on. I think they just want the users to come to them. They want to be able to accept any token. And I hope in the future we'll have things like the user pays me in Binance token, but actually I get DAI back because I want stable coins because I actually have bills to pay. I think that these kinds of things, all these niceties are what's going to actually make dApps happen. And what I hope is we don't have another 100 new infrastructure projects this year, but we have like 100 new dApps, and then we actually see like real usage on the blockchain. So that's it. I have plenty of time for talks or to go into any detail of any section that I lost over. Anybody have a question? Cool. Any other topics? Anything that you'd like me to go into more detail on or questions about?
Regarding rolling updates, about infrastructure, like how do you deploy your stack, like in Kubernetes or?
Right. That's a good question. So the question was, in case the camera can't hear it, is how do we deploy it? So you can't run a blockchain on Kubernetes, despite what anybody will tell you. So the thing is blockchains are incredibly disk-based, and they're incredibly sensitive to the latency of the disk. And it doesn't make sense why you would run it on Kubernetes either, because typically you have disparate validators that are running the nodes, right? So they're separate instances, typically they're on physical hardware, because if you run, it depends on how high value your blockchain is, but higher and higher value blockchains will need things like HSMs and physical hardware, because one of the other issues is if you're running your blockchain on a virtual machine, whoever the provider of the virtual machine is could steal the private keys from the machine. I mean, now granted, with Amazon or Google, that's probably a smaller risk, but I think that the more you get closer to physical machines, you have a lower risk factor. As far as deployment, we internally use Ansible. I think I'm kind of convinced that that's probably the easiest way to manage like a physical machine, because you don't have a lot of dedicated nodes. Even for us, we maybe have 12, 15 boxes that are actually like validators or caching nodes or something like this. Yeah. Cool. Anybody else? Are you building a blockchain or?
Yeah, working with.
Okay. Which one?
With timeless.
Okay. Cool. Awesome.
I have a question about testing. How do you test distributed system?
Oh,
Because it's a kind of, how should I put it, a kind of really special pain. Yeah.
This is great. I love this question. We have 5 different things that we do. So of course, we always start with the unit test. That's obvious. For every piece of our system, we have integration tests. And an integration test means you write a client to the blockchain that submits transactions, and our integration test framework will spin up a 1-node cluster, a 4-node cluster, and an 8-node cluster. So that way you can see if you have upgrade problems, you have different issues, or if you're doing things on certain nodes that are not being reflected on other nodes. Once it goes through that, every single commit goes through our integration tests. So all of our tests are being run, every single commit to Git. Then usually once a day, we deploy to our internal testnet. And basically all the developers at our company are building a bunch of dApps, and they're running against the internal testnet. When that goes well, we have an external testnet, and our external testnet has about 30 or 40 different dApp developers that are building on it. There's a bunch of people also just running non-validating nodes on the network. It's usually a good test of like,
So it's like a big simulation. Yeah?
it's a big simulation, but people are actually using it for work. So we actually have to deploy something quite good, because if we push something bad, then we have like 100 people in the chat room complaining why the testnet doesn't work, right? Because most people, at least for our chain, are not developing with the local nodes. They just literally develop against the testnet. And then once we've passed all that, we have non-validating nodes that run query nodes. So like, the Block Explorer has dedicated nodes that it queries against. We'll start upgrading those. Then we'll take one validator that we run internally, and we'll upgrade it to that version. Let it run for a day or two. Then what we do is, after a day or two of that, we distribute it to all the other validators. They all upgrade. But any new feature has not been activated yet. So each feature gets individually activated once it reaches a certain percentage of the network. And then we slowly but surely, over a couple days, will activate a new feature. That way we have like the most testing, the most regressions. It's not perfect, but this is the best that we've found for at least for our scale.
Thank you.
Cool. Awesome.
Since you upgrade so often, what best practices have you found for coordinating with validators?
Wow, this is a difficult one. I know we have a validator here, so I'm sure he's keen to. Yeah, so I think coordinating with validators this is a really tricky subject. For us, we've been moving very fast. So usually we give validators a couple days notice, hey, there's gonna be an update later this week. These are the features. And the features don't turn themselves on automatically. So the reason we do that is, okay, we can quickly get everybody to upgrade nodes. And then if there's even more time if there's something contentious about a feature. Like they're like, oh, well, this feature doesn't make sense. We can still have everybody upgraded, and we can find out if we can upgrade that feature. But there may be 3 or 4 features in a release. And one contentious feature doesn't blow out the release because we can just say, okay, well, people don't like this, we're gonna just upgrade this. Now, we've had situations where, for example, we had one of the games was ramping up, and they had a 500 user tournament that was running over a weekend. And they generally generate a couple million transactions a day when they run one of these tournaments. And we needed a big performance fix to go out in like 2 days, right? This was one of those trying times where we were like, hey, everybody, we're really sorry, but we have to get this out very quickly. There's some people that like we had to call and like, hey, I know you're flying today, but could you really just upgrade from the airport? We're really sorry about this. And it's not ideal, but I don't know of a better way. I think that this is going to be an ongoing conversation with basically everybody in the industry. Cool. Awesome. Maybe one more if anybody has it. If not, I'll close it. Cool. Awesome. Thank you guys.